Hello everyone, how is everyone doing? I hope everyone is having a good time and they are solving questions, right? And queries are coming up, right? If you have any queries, remember during the class you can please make sure you can comment down below, all right? And we are continuing our discussion, AIATS plus phase 2, right? And mock test 3, it was conducted on 2nd February, right? So let's continue. This is slot number 4, remember that? So we're going to be discussing few topics, right? And as you can see, the bulk of our topics today is going to be from 11th class, right? And one 12th class topic, atoms, which we are also going to discuss. All right, very well. Very well. And let's continue our discussion of laws of motion from where we left off last time. If you remember, last week, under slot number 3, we were covering under laws of motion, angle of repose, right? Block is kept on an inclined plane, it is left, and we were trying to find out what is angle of repose and how is it connected to friction, right? And we had found that coefficient of static friction, it is equal to tan of theta p, where theta p is your angle of repose, right? We had studied this same diagram and everything. If you want to rewind that topic, please go revisit my video last time, which I had done with you guys, right? So angle of repose, right? So let's say I'm calling it as theta r. So r for repose, right? And we had eventually concluded that mu s, right, the coefficient of static friction, it was coming as tan theta r, isn't it? Tan of theta r. And remember, we were also talking about what was the connection between this theta and this theta p, right? So if you see, theta is the angle of inclination of the inclined plane, right? So what happens, right? So what happens, let's say theta is less than your theta r. We were talking about it last time, remember? And theta r is less than your theta, right? Theta r less than theta means what? That the angle of the inclined plane is more than the angle of repose. That means the angle of inclination is more. What does that mean? That the block is going to come sliding down, right? So block slides down, isn't it? And which friction will come into play? Because there is slipping, right? Block is going to slip as it comes down the inclined plane, right? It's not static on the inclined plane. So which friction comes into play? Kinetic friction, isn't it? We talked about it. And I had also told you, you can find acceleration as well of the block that is coming down, right? Because you know the force acting down the incline, that is mg sine theta. Force acting up the incline, that is your kinetic friction, equal to Fk, equal to how much? Kinetic coefficient, right? Coefficient of kinetic friction into normal force. And normal force on the block was how much? This is the normal force and it was equal to mg cos theta. So we can directly write it is mg cos theta, right? And what about this case? That means the angle of inclination of the inclined plane is not sufficient for slipping. That means the block is going to stay at rest. That means static friction comes into play, right? And there is no need for maximum value of static friction. The block will stay at rest, right? So this we had finished off last time and I am revising it just so we are going to do some more problems of it, okay? Block stays at rest. Very well. And static friction comes into play, right? If you want, you can write down static friction. All right, very well. Let's move to our first question, right? This question had come in your AIATS. If you see here, mass is given of the block, m equal to 1 kg, resting on an inclined plane of angle 30 degree. Theta is also given, angle of inclination of the inclined plane, right? So which means you can find tan theta, right? Tan theta would mean how much? Tan 30 degree. Tan 30 degree is how much? 1 by root 3. 1 by root 3, and if you rationalize, multiply by root 3 in the numerator and denominator, it becomes root 3 by 2. Okay, so root 3 by 2, so 1.732 divided by 2. Okay, so it roughly comes out as 0.8 or whatever, right? Then you have coefficient of friction is given, right? Coefficient of friction is mu. So mu is given as how much? 0.2, right? So which means under when the block is just about to slip, so what would be the angle of repose? Angle of repose, just what I told you, right? It should be equal to tan theta, isn't it? So mu should be equal to tan theta. This is which theta? Tan of angle of repose, right? And as you can see, which one is bigger, 0.8 or 0.2? Obviously this one is bigger, right? So which means theta will be more than theta r, isn't it? Theta will be more than theta r. That means block starts slipping, right? Block starts slipping. And if you want to talk about the forces that are acting on it, right? mg sin theta down the incline, isn't it? So I'm not drawing the incline plane again. I'll just draw it like this in short form. mg sin theta down the incline. So mg, m is how much? 1, g is 10, right? So let me just write down mg sin theta. And block slipping means frictional force, kinetic friction will come into play, and that would be equal to how much? Mu k into normal force mg cos theta, right? That's what we had written over here, mu k into mg cos theta. This is going to prevent the block from slipping, but obviously the block is going to slip. The block is, right, the block is moving down the inclined plane. So mu k into mg cos theta, isn't it? Mu k is how much? 0.2. mg, m is how much? 1 into 10, right? Cos theta, right? Or cos 30 degree, isn't it? So if you want, you can find out what does this become? 2 root 3 by 2. That means root 3 Newton. And if you want, this also you can find out 1 into 10 into sin 30, that is 1 by 2. So this becomes 5 Newton, right? If you want, I can directly write down 5 Newton. See here. So I'm directly writing mg sin theta. This one is root 3 Newton. Block is coming down the inclined plane, so acceleration would be a, right? And what would be the net force? Net force would be, see, downward force is more, so downward force minus upward force. So 5 minus root 3 is your net force. So what would be the acceleration? Acceleration is net force upon mass, right? Net force is how much? 5 minus root 3, right? 5 minus root 3 upon mass is 1 only, right? So 5 minus root 3 meter per second square. Okay. And what is the initial velocity of the block? Read the question carefully. A block of wood is resting on an inclined plane. Resting means u equal to 0, isn't it? Initial velocity equal to 0. Now which equation we will use? The first equation, right, of motion. If you remember, v is equal to u plus at, isn't it? Because the acceleration is constant. So v is equal to u plus, u is 0. So v would be nothing but a into t, right? And time, after how much time we have to find out? 5 seconds, right? So this into 5. Okay, this into 5, so you can solve it, you will get your answer, right? So we have to find velocity after 5 seconds, that's all. You have to solve the question. Very well. So please note it down. All right. So this was the crux of the question, and in fact there was no need to do all this analysis, but I want to connect this topic with that topic that we did that day. All right. Very well. So let's move on. See here, I've written a question for you guys. If you see here, I've drawn a block has been shown to be standing, or let's say lying on an inclined plane of inclination 37 degree, and the block is coming down, right? Coming down with constant velocity. right? We can take the constant velocity at any value. Let's say I'm taking the value as, let's say I'm taking it as 15 meter per second. This constant velocity doesn't matter. It's irrelevant, in fact. And they're asking you to find coefficient of kinetic friction. Now, again, remember, the block is moving down, right? That means, and it is moving with constant velocity. And constant velocity means acceleration is 0. And acceleration is 0 means net force will also be 0, right? Net force on the block will be 0, isn't it? So we can say, see here, net force will be 0. That means upward force would be equal to downward force. And what would be downward force over here? M is the mass, right? Let's say mass also we are taking it as 15 kg. Okay, you can take it, mass is equal to 15 kg. But by the way, mass is also irrelevant, so it doesn't matter. So what is the downward force would be? mg sine theta. We have done so many questions, right? mg sine 37 degree, right? So mg sine downward force. It would be equal to upward force. And which force it would be? Kinetic friction. Why kinetic? Because it is slipping. The block is moving on the inclined plane, right? So mu k into normal force, or mu k, I am simply writing it as mu only. If you want, you can write mu k also. Into normal force was how much? mg cos theta, right? Normal force was mg cos theta. Please remember this diagram. Okay, there's no need to draw this FBD again and again. If you know downward force and normal force, you can easily do the question. So it would be mg cos 37 degree, isn't it? So now if you see from here, which terms are going to get cancelled? See here, mg and mg will get cancelled, right? And what does that become? Sin 37 by cos 37, that is tan 37, right? Tan 37 would be equal to mu k. And that's what they are asking, coefficient of kinetic friction. So mu k will be tan 37. Tan 37 is how much? 3 by 4, isn't it? If you want, you guys, please remember this right angle triangle as well, okay? So let's say this is 37 degree and this is 53 degree, right? Smallest angle 37, the side opposite to it will also be the smallest. 37 opposite 3, 4 and 5, right? So tan 37 is 3 by 4. 3 by 4, if you solve it, it will come 0.75, right? All right. Yes, good afternoon, good afternoon. Few students, they are joining in. All right, very well. Now see here, so 2 questions we did from inclined plane. So let's take a small break. Let's do a simple problem on plane surface, right? Let's say I'm taking 2 blocks on this plane surface. Okay. Let's say this one is 2 kg and this one is 4 kg, right? And we have connected them by a string, right? And this surface is frictionless. So here in this question, I'm trying to make you guys revise Newton's second law. And let's say forces are there on these blocks, right? Right side force is 20 Newton, right? And left side force is how much? Let's say we can take any value. Let's say I'm taking 60 Newton. We can take any value you want. So which force is higher? That force is higher. So that means if you take this whole as a system, how is the system going to move? Towards left. All right. So with that in mind, take this question, right? Let's say initially system at rest, right? And find final velocity after 5 seconds, right? That was the question here, isn't it? Find velocity after 5 seconds. So same I'm giving. Find, but velocity as in whose velocity? Take any block you want. Let's say velocity of 2 kg block, okay? So find velocity of 2 kg block after 5 seconds. After 5 seconds. This question might seem, again, it might seem complicated, but it's not that complicated, right? I shared the gist of that question, shortcut, last time also. You can check last week, right? Good afternoon, Amit. All right, so how will we do this question? Very simple, right? Without drawing FBD, also you can do this question. How? You can take this whole as a system. Remember, there is no frictional forces acting over here, right? So whole as a system, what is the mass of this whole system? 2 plus 4, right? So total mass, 2 plus 4 is equal to 6 kg. And what would be acceleration of this system? Can you tell me? Acceleration would be net force, right? Net force upon total mass. Net force is how much? 60 minus 20, that is 40, right? 60 minus 20, that is 40 Newton upon the total mass is how much? 2 plus 4, 6. So solve it a little bit, it becomes 20 by 3 meter per second square. And remember, they both would have the same acceleration, isn't it? If they don't have the same acceleration, then the string will break, right? Because at some point of time, they will have the same different velocity. Different velocity means the string will break. Okay, someone is asking, sin theta is responsible for friction at surface to balance weight of blocks. Okay, now in this question there is no friction obviously, and there is no sin theta as well, right? Whereas in the inclined plane, yes, there was a sin theta, but who was balancing the weight? That was the cos theta term that was balancing, isn't it? Or we can say the normal force was balancing the mg cos theta, which is the component of weight. All right, very well. See, acceleration we know, and velocity of, let's say, 2 kg block, right? So 2 kg block is going to move towards left with this acceleration. Initial velocity was how much for 2 kg block? 0. Constant acceleration. So v is equal to u plus at, right? Use it. So 0 plus a is how much? 20 by 3. Time is how much? 5 seconds. That's it. You got the answer. 100 by 3 meter per second. See here, 100 by 3 meter per second. So now tell me, was it lengthy? I don't think so, right? If you know how to solve, I don't think it was lengthy. All right, anyway, let's move on. All right, let me give another question. Again from inclined plane, right? Before I move to next topic. So let's say this angle is 30 degree, angle of inclination, right? And let's say we have a mass over here. And let's say coefficient of friction, right? It is given as 0.8, which means this is not a smooth surface, it's a rough surface, right? So block can slip if it wants. So rough surface, right? And obviously mass m is given. So now can you, you have to tell me, find frictional force, right? Find frictional force in terms of mass m and g, right? What's the frictional force that is going to act? Once again, this question is connected to your angle of repose, the same topic, right? How? See here, tan theta, the same tan theta, right? So tan 30 degree is how much over here? Tan 30 degree or tan theta, right? So tan theta is tan 30, right? It was roughly equal to 0.8, right? Roughly. Okay, it was roughly 0.8. Okay, this is coming closer, isn't it? So let me alter this question a little bit to make things more simpler. Otherwise, see here. Let's say I'm taking mu as 0.9. Okay, mu as 0.9. So here if you can see, if mu is 0.9, that means angle of repose would be given by how much? Tan theta r, it is equal to mu, right? that will be equal to 0.9. Okay. Actually, it would be 0.855, but for simplicity purposes, I have taken 0.8. So now if you compare, right, so which theta would be bigger? Theta r only, right? This theta would be smaller, isn't it? So we can say theta is less than theta r. That means angle of inclination of inclined plane is not enough. If it is more than theta r, the block will slip. But right now, it's not enough. That means the block will stay at rest only. Okay, block will stay at rest. And what would be the value of frictional force? Right? Remember, this was the frictional force acting, and downward force was how much? mg sine theta or mg sine 30 degree. So frictional force would be equal to, would it be equal to that maximum value mu mg cos theta? It won't be. It won't be, right? Why? Because that much, that value would be much higher, isn't it? So this mg sine theta is much smaller. So frictional force, which is static friction. All right, if you want, you can write down static friction equal to mg sine 30 degree. Okay, so mg by 2. All right. So I think multiple questions we have done, right? One where theta was less than theta r, another theta is more than theta r. Okay, so let's move on to some different topic. See here, a ball is dropped from a height of 20 meter. It is dropped, right? Dropped as in just dropped like this, and dropped meaning what would be the initial velocity of the ball? Initial velocity of the ball u will be equal to 0, right? And how much height from which it is being dropped? This h is equal to 20 meter, right? And then they are saying coefficient of restitution. They have given coefficient of restitution also we talked about last time. We denoted it by the symbol E, right? And impulse imparted to the ground that we have to find out, right? So let's say that this is the ground, right? And we are dropping the ball from above. That means initially u would be equal to 0, right? And what would be the velocity with which the ball will strike the ground? That can we find out, right? Can we find that velocity? Yes, we can, right? Because this height is given, height h is given. So v would be equal to how much? Under root 2gh, right? Using which equation of motion? You can use the third equation, right? V square is equal to u square plus 2gh, right? So let me write down v square is equal to u square plus 2gh. So u is equal to 0, right? So that means v is coming how much? Under root 2gh. And you can put the values if you want. H is how much? 20, right? And g you can take it as 10. So 2 into 10 into 20. 2 into 10, 20, right? So 20 into 20, 20 square. Root 20 square would become 20 only, right? So that means with 20 meter per second, it is falling on the ground, right? With falling on the ground. Now tell me, I'm asking you a simple question. See here, for example, let's say this was a ball, okay? It's not a ball, but let's consider it as a ball. So for example, if you are dropping this ball like this, if you're just dropping it, right? Let's say I'm dropping it from this much height. So after the ball strikes the ground, will it rise to the same height? Is it possible? If you want, you can try it at your home, right? You can pick a random ball, you can try. If you drop it, it will never rise to the same height. It will never rise. Why? That is because obviously there is air drag as a factor is also there, but one of the main factors is this one, coefficient of restitution, right? Because of which the ball, after striking the ground, it loses some of its speed, right? So after striking the ground, it will rebound with less speed. Okay, so if it is striking with 20 meter per second, it will rebound with less speed. That's why. Very well. E we studied last time. Do you remember? E we studied last time. E is equal to what? I will write separately. So E is equal to velocity of separation of the two bodies upon velocity of approach of the two bodies. Right? Now if you remember, I said that the ball is striking, right, with how much speed? 20 meter per second, and let's say it is rebounding with how much speed? V. Okay, so let's say I'm drawing it over here. It is rebounding with speed V. Okay, obviously it's going to rebound here only. Okay, I've drawn it little bit away. All right. So now if you can see, it is approaching the ground. Right. So put the values over here. Velocity of separation. So during this, which velocity we will take? This one, because the ball is separating from the ground. So velocity of, or if you want, a better way to write would be relative. Okay, so it is relative velocity of separation. So velocity of separation of ball with respect to ground, or we can just call it relative velocity of separation. If you want, you can write down relative over here, or I hope you understood what I'm trying to say, right? That is velocity of separation of ball with respect to ground, or relative velocity. So tell me, what is relative velocity of separation of ball with respect to ground? It will be V only. Why? Because ground is at rest, right? A ball is only moving. So this relative velocity of separation, it will become V only. And what would be relative velocity of approach? It is 20 only, isn't it? Because ball is approaching with speed 20 meters and ground is like that only, even after the collision. So V by 20, it is equal to E. Right? So what would be V from here? V is equal to 20E. All right, V is equal to 20E. So if you see from here, V is given, E is also given. So what is the speed with which it will rebound? Let me draw this diagram over here. Let's say this speed is V dash, right? So this V dash would be what? E into this V. Right, E into V. E is how much? 0.9. So 0.9 into 20. That means it is how much? 18 meter per second. That's just what I was saying, right? It won't rebound with the same, so it will rebound with less speed. Very well. That's not we are supposed to find. They're asking impulse imparted to the ground by the ball, right? So what would be impulse over here? If you see, during the collision, right, what is the ground doing? In what direction? The ground is applying a force on the ball. The ground is trying to push the ball upwards, right? So we can say this impulsive force is acting upwards and impulsive force on the ground is acting downwards, right? So impulsive force, or we can just call it impulse, right? Impulse would be change equal to change in momentum, or we can just write F into dt. Why dt? Because this collision is taking place for a very small time. So force multiplied by that small time interval equal to change in momentum. Change in momentum. How will we find that? Change in momentum would be equal to final momentum minus initial momentum. Final momentum is what? Mass into this velocity. So m into v minus final minus initial momentum. Initial momentum, if you see, it was m into 20, but this final momentum, remember, momentum is a vector quantity, right? So we have to write it with the direction. So this momentum, if you are taking it as positive, this momentum will be negative, right? So this momentum will be negative. All right. So final momentum is m into v minus initial momentum. Initial momentum will be 20 into m, but with a negative sign. Right, but with a negative sign, right? So what does it become? See, m into v plus 20, right? So if you go over there, that impulse, and remember the impulse applied by the ground on the ball, it is same as the impulse applied by the ball on the ground, right? So impulse would be equal to, mass is how much? 1 kg, 1 into final velocity 18, right? 18 plus u, isn't it? 18 plus 20, that's what we have done. So 18 plus 20 is how much? 38. And impulse, obviously, it would be in Newton per second, isn't it? Why Newton per second, or Newton second in fact? Why Newton second? F into dt, right? Force is in Newton and time is in seconds. All right, very well. Before going, I will try to give you one good problem as homework for this impulse topic. So let's move on to gravitation, right? Yeah, 38. Sudhakar has said the right answer. 38 is the correct answer. Very well. So under gravitation, if you remember, we had covered some topics such as conservation of angular momentum, right? Then we had covered torque is equal to 0. Then we had talked about aerial velocity, right? So today we are talking about something else, right? Something else, as in, let's say this is the Earth, right? We are going to talk about satellites, right? So let's say a satellite is revolving around this Earth in an orbit of radius small r. Okay, so let's say the Earth has mass capital M and radius capital R, right? And this is the satellite, right? And this is the center of the Earth. This is the satellite over here. And this satellite is going to revolve around the Earth in a huge orbit. Okay, I can't complete the whole circle, but you will understand what I'm trying to say, right? So what would be the radius of this orbit? It would be equal to this capital R plus this height, isn't it? Or for now, let me just write it as small r, right? This is small r. And what would be the velocity of this satellite? Let's say it is moving with a speed v in that direction, right? So let's say it is moving with speed v in that direction. And its mass is how much? Mass is m, right? So, and we had also talked about gravitational force. If you remember, what was the gravitational force acting on this small body m? What would it be? Equal to g, tell me. Gravitational force, right? Gravitational force, what would it be? G, one body's mass is capital M into another body's mass. G capital M into small m upon, they are separated by how much distance? Small r. So small r square. This is the gravitational force, right? And what am I writing over there? Centripetal force. Why? Because any body that moves in a circle, you can always write it, say that a centripetal force would be acting on it, right? Centripetal force. Now see, let's see what we are trying to do. We will get a formula from this one. Centripetal force, what's the formula? M v square by r, right? Mass of body or mass of satellite, velocity of satellite divided by radius of orbit. Please remember this formula as well. And you can cancel terms. M cancel, r and r square cancel. So from here, you will get an expression for velocity, right? So v square equal to gm by r, or v is equal to under root gm by r. Okay, under root gm by r. And if you remember, one more topic I had discussed in gravitation, I had said that when the satellite is revolving in an elliptical orbit, the angular momentum of the satellite, or we can say angular momentum of the planet, which is revolving in an elliptical orbit around the sun, angular momentum of planet will remain conserved at each and every point, right? Similarly, if the satellite is revolving in a circular orbit around the Earth, angular momentum of the satellite will remain conserved. Why? Because torque is 0. Why torque is 0? Because the only force is gravitational force, and you see gravitational force is in this direction, r vector is in the opposite direction, torque will be r cross f, rf sine 180, torque is 0, angular momentum is conserved, right? So can we write down angular momentum over here? Can you tell me? Angular momentum, right? Angular momentum would be equal to L, and also I had said that in elliptical orbit, you cannot say L is equal to mvr always. You would write L is equal to mv r perpendicular, because v and r are not perpendicular in ellipse. But here, this v and r are always perpendicular, and r is obviously the radius I'm talking about, right? So L is, directly you can write magnitude of L is mvr. Okay, so put the value of velocity over here, right? see what we are trying to do, right? What we are trying to do, see here carefully. Here I have proved that velocity is proportional to 1 by r, right? Here we are trying to find out L is proportional to what power of r. That's what we are trying to do, right? So put the value of velocity over here. See what it becomes. L is equal to m, then under root gm by small r into r, right? So what does it become? M under root gm, r power how much? 1 by 2, right? R power 1 by 2. So always remember, just because L is equal to mvr doesn't mean that angular momentum is proportional to r, because here in fact angular momentum is proportional to r power 1 by 2. 1 by 2. See here, this result you can use it in the next question. See here, see this question. They have said two satellites of same mass as in mass m, are revolving around Earth in circular orbits of different radii, that small r, right? That radii of that orbit is different, r1, r2. And we are asked to find ratio of angular momentum, L1 by L2. So L1 by L2 we have to find out. But just now we proved, right, that for the satellite angular momentum will be proportional to r power 1 by 2 or under root r, right? So here L1 by L2 would become what? Simply r1 by r2, right? And if you take the ratio r1 by r2, 4 over 9, right? What does it become? 2 by 3, isn't it? Simple. So some students might make the mistake that L is equal to mvr, so that means the answer should be 4 by 9. And in fact, in the options it's not given, but if 4 by 9 had been given in the options, some students will directly tick the answer. So please don't make that mistake. So the answer would be 2 by 3 over here. So let's do a similar question, another. See this question. Again, same question I had written, but something else I'm asking, right? Same equal mass around the same planet Earth in radii r1, r2. Ratio of time period I'm asking, right? Ratio of time period I'm asking, right? In fact, you can do this question in a similar way. Instead of it being two different satellites, let's say that when satellite A is at a radius 4r, time period is t, and when the same satellite goes to a radius 9r, what will be the time period? Right? For the same satellite also, we could have I could have twisted the question. All right. So here, what do we have to do? If it is the same satellite, all you have to do is use which law? Kepler's third law. You can use, because the planet is the same. You are changing the orbit of the satellite, right? So different orbit r, radius r, so different time period, isn't it? So that's all you have to do. So what was Kepler's third law? T square is proportional to r cube, right? So what would that become? You can try to solve it, isn't it? So T1 by T2 whole square is equal to R1 by R2 whole cube. That's what this implies. R1 by R2 is how much? 4R by 9R. So that becomes 4 by 9 whole cube, or 64 by 729, right? And what would be T1 by T2? Because that's what we are asked to find, right? T1 by T2. So T1 by T2 would be how much? You have to take square root. Square root 64 is 8, and that one is 27. So 8 by 27 is the answer, right? So that way, see, different formulae, etc., they are being connected like this. Okay, so you can remember things like this. Very well. So I hope everyone has understood, right? Gravitation, right? Very well. See this question. This also we have done pretty much almost the same question, right? For a perfectly rigid body, bulk modulus is infinite, right? That day we had talked about incompressibility and compressibility, right? We had said that if bulk modulus is high, that means incompressibility is also high, right? And we had also discussed the formula for bulk modulus, isn't it? So what was the formula? Change in pressure upon fractional change in volume. So fractional change in volume like this, but with a negative sign. Okay, why negative sign? Because if you increase the pressure, volume will decrease, right? So here we put minus sign over here. Very well. So if you see, for perfectly rigid body means you can't change its volume. You can't change its volume. That is because it is what? It is incompressible. Okay, it is incompressible. That means delta V would be equal to 0. Right? You can't change its volume. Highly incompressible, so bulk modulus would be very high. How high? See, put delta V equal to 0 here. What would B become? B would become how much? Infinite. Right? Because anything divided by 0 would become infinite. So this is correct. Right? And why is this? Because reason, change in volume is always 0. That is also true. Right? Change in volume is 0. That is why bulk modulus was infinite. So the correct answer would be yes, reason is the correct explanation of assertion. Okay. And last time we had also said that if the body is highly compressible, that means the bulk modulus, would it be high? It won't be. It would be low. Because why? Because highly compressible means incompressibility is very low, bulk modulus is also low. All right, so moving on. Next topic, see here, work energy power. We had done some, last time we had done some very interesting questions, right? We had done force changing with time, we had found the work done. Then force changing with position, we had found the work done. Force not changing at all, constant vector, we had found the work done. So today see how the force is changing. See here, how is the force changing here? Force is changing with position here, right? And force versus displacement graph is given. It's a moving body, obviously. And total work done, we have to find out. Total work done. How did we find total work done? Last time, if it is a variable force, right? We can do, one thing is we can do integration, right? Integral f dx. Or if force versus position graph is given, or force versus displacement graph is given, you can directly find area under the graph. So that would be equal to your work done. So area under the graph we have to find out. Area under the graph, right? Which means this is the area under the graph. And this area as well. I will shade it with a different color if you want. Yeah. Right. So can you tell me what will be this area, the first area? It's a simple triangle, isn't it? What is the area of this triangle? Half into base into height. Right. So this I am writing it as A1, this as A2. Right. So work done would be nothing but A1 plus A2, taking into account the sign, if it is positive or negative. Work done can be positive and negative. Potential energy can be positive and negative. Kinetic energy can't be. So what is the area of this triangle? Half into base into height. Base is 10, height is 10. So half into base is 10, height is 10. Okay. Okay. Then what about this triangle? This triangle's area would be negative. Area would be negative. Why? Because negative force is acting. See, for this one, force is below this x-axis, right? So force is negative, area would be negative, work done would be negative. So what is the area of this one? Also half into base into height. Base is how much? 10 to 15. Base is 5. So half into base is 5. Height is how much? This one. Height is 10, but we will write minus 10. Okay. We will write minus 10. So you just have to solve it, right? 10 into 10, 100 by 2, 50. 50 by 2, 25. So the answer would be 25 joule. Okay, 25 joule. In place of this, if I had, let's say, this area was above x-axis, then what would you have done? then also A1 plus A2, but that A2 area would have been positive. So instead of 50 minus 25, it would have become 50 plus 25. So it would have become 75 joule. All right. It would have become 75 joule. All right. Now let's say I'm giving you another question over here, right? Let's say initially for the same graph, let's say initially the body is starting from rest, initially at rest. Okay. So let me write it down. Initially at, the body is at rest, right? Find the velocity attained by the body. Obviously body means you have to give the mass of the body. So I'm giving mass as 2 kg, right? Mass of body is 2 kg. So find velocity attained by body. This question is also a little tricky, so please observe when it reaches position, or let's say when it reaches displacement 5 meter, right? I think better way to write would be x equal to 5 or displacement equal to 5 meter. Which means this point, right? So from here to here, in here velocity was 0, here velocity we have to find out. At x equal to 5 we have to find out. So how will we do this question? How will we do the another formula for work done, which I had made you write, right? What was that one? Work done is equal to change in kinetic energy, right? Work done is equal to change in kinetic energy. So K final minus K initial. Now what would be work done? It would be area of, not the whole triangle, only the small, this portion of the triangle, right? Because only from x equal to 0 to 5 we are concerned about. So what would be area of the small triangle? Half into base into height. Base is 5 only. Height is 10, right? So work done would be half into base into height, right? Kinetic energy, it would be half mv square, half into mass is how much? 2 kg into v square. Initial kinetic energy, I had given it as 0, right? I wrote initially at rest. So therefore, initial kinetic energy equal to 0. Okay. So if you see here, 2 get cancelled. 50 by 2, 25, right? So v square equal to 25. That means velocity comes out to be 5 meter per second, right? At x equal to 5 meter. See, you have found x equal. Similarly, you can find the velocity at various other positions as well. All right? Okay. Moving on, the last chapter and the last topic of the day, atoms, right? And if you remember, we had talked about Bohr's second postulate last time, right? So today we are going to discuss a little bit about Bohr's third postulate, right? Bohr's third postulate. What does that mean? It means that when an atom, right, or we'll say when an electron in an atom jumps from higher orbit to lower orbit, what would it do? It has to lose energy, and it will lose energy in the form of photon, right? And that energy of photon, right, energy of that photon can be written as h into nu, where nu is the frequency, or we can say it is equal to h into c by lambda. Lambda is the wavelength, right? And this would be equal to what exactly? As I said, it moves from higher orbit to lower orbit. So high energy orbit to low energy orbit, it is coming, right? So you can remember it like this: higher energy orbit to lower energy orbit, right? And what was the formula for E that we had studied? E is equal to, let's say, energy in nth orbit, right? We had studied E is equal to minus 13.6 electron volt upon n square. For which atom? Hydrogen atom, right? Similarly, the value of n would be something for higher orbit, similarly for something for lower. And then if you see over here, h and c, right? H is Planck's constant, c is speed of light, which is 3 × 10⁸ meter per second. So if you take into account all these constants, put it to one side, you will get an expression in terms of lambda only, right? So you will get 1 by lambda equal to, all these constants are lumped together, right? R, right, upon 1 minus n square upon 1 minus n square, that is n1, that is n2, right? This R is called Rydberg's constant. And obviously, as the name suggests, it's a constant, okay? Its value cannot change. So let's say if it is coming from one n to another n, you can find the wavelength that is involved in that transition. You can also find the energy that would be emitted by the electron, or let's say energy of the photon. See here, this is a nice diagram, right? It's showing the same jumping from one end to another end, right? So if you see here, if it jumps from, let's say, any orbit to n equal to 1, and remember this is for hydrogen atom we are talking about, okay? Right? And for hydrogen atom, what is the energy of that first orbit? That is minus 13.6 electron volt. So from higher orbit to Lehman series, it becomes, if it jumps from higher orbit to first orbit, right? Then similarly, if it jumps from higher orbit to second orbit, it becomes Balmer series, right? So let's say it is jumping from 6, n equal to 6 to n equal to 2. And I'm asking you to find the wavelength. So what will you do? Here you have to put n equal to 6 and n equal to 2. And you will get the corresponding wavelength in terms of R, right? Lehman, Balmer, Paschen, bracket, and Pfund, okay? And if you tell me, why is it that this series is, let's say, visible, or let's say if Balmer series is visible, then will the Lehman series, would it automatically be ultraviolet? Would it be? It has to. Why? Because if you see, the energy of the photon involved would be more, right, when during the transition in Lehman series compared to the transition in Balmer series. So the energy would be more, that means that the wavelength would be less, right? And if this involves visible, so this wavelength over here should be less than the wavelength over Balmer, right? So wavelength should be less than the wavelength of visible light. That means it comes out in the range of ultraviolet. Okay, for that obviously you have to do the calculation and find out whether it is actually ultraviolet or not. Okay, see here, let's do a question, right? Here what are they saying? The last line of Balmer series, right? Last line of Balmer series. So for Balmer series, I told you, it is coming from any value of n to n equal to 2, isn't it? So last line of Balmer series means it is jumping from, let's say, n equal to infinity to n equal to 2. What would have been the first line of Balmer series? It would have been n equal to 3 to n equal to 2. Okay. And similarly, last line of Lehman series would be what? Again the same, n equal to infinity to n equal to 1, right? Now we have to find the ratio of their wavelengths. So first let's write the wavelength involved over here, right? This is the last question of the day. So what is the wavelength involved over here? Same formula, lambda. For Balmer, let me write B, R, 1 by n square minus 1 by n square, right? So I will write 1 by 2 square minus 1 by infinity square, that is infinity only, and 1 by infinity will become 0, right? So instead of here, I will directly write 0. Okay, I will directly write 0 over here, right? And similarly over there, for Lehman, 1 by Lehman lambda L is equal to R multiplied by 1 by 1 square minus 1 by infinity square, that's also 0. So from here, what are you getting? Lambda B as 1 by lambda B, R by 4, so this becomes 4 by R, right? And this Lehman series becomes R only, right? wavelength for this transition is r only. So we have to take the ratio, right? So if you take the ratio, what would it become? Lambda b over lambda l, right? 4 by r. 4 by r. Oh, wait. Here it should be, yeah, it would be 1 by r, right? Because 1 by lambda is r, so our lambda would be 1 by r. Okay, so take the ratio, so 4 by r over 1 by r. So the ratio would be 4 or 4:1, right? 4:1. Yeah, thank you, Dasrath. All right, very well. So I guess we have come to the end of our lecture. Okay, and I hope you guys had a great time. And don't worry, we will cover some more good questions next time. Okay, thank you.